Okay guys, here's my video for 1F, and you can see I actually have the exact problem that I assigned you guys. And the problem says, do the segments connecting the coordinates -1, 6, 4, 2, and 7, 6 form a right triangle? Show the work that leads to your answer. Now we're kind of switching gears a little bit now with this problem, and this becomes a little dicey, and that's why I wanted to make sure I actually used your problem and show you what you need to do now. All right, so if you actually label the points and graph them, -1, 6 is here, 4, 2 is right here, and 7, 6 is up here. And then I kind of just drew some dotted lines here, and that's a solid line to kind of show you what it would look like if you connect them to form your triangle. Now, they're kind of assuming that the right angle, if it is a right triangle, is right here. All right, so now what do you do to go about solving this? Well, you can't really use Pythagorean theorem here because like these dotted lines, you can kind of see they're not even the diagonals of these little small squares. So we don't know the side lengths. So what needs to happen, I need to find the slope of this side here, and I need to find the slope of this side over here. All right, and then I'm going to compare those slopes. So I'm reminding you that the slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now for this side, you'll be using the points 4, 2, and 7, 6. I show you that here. I even show you the substitution. So you're going to go y sub 2, which is your 6, minus your y sub 1, which is your 2, all over x sub 2, which is the 7, minus x sub 1, which is your 4. Now, you're going to do the rest and simplify that, and you're going to get a fractional answer. Then you need to find the slope of this other side that I have kind of with these dotted lines, and you're going to use the points -1, 6, and 4, 2. And again, I'm showing you that here. So there's the slope formula again. Now, when you sub in then y sub 2, you're going to take this 2 here minus y sub 1, which is 6, over x sub 2, 4, minus x sub 1, which is -1. Now you're going to simplify this also. Now remember in this denominator, when you have the two negative signs, that it's going to turn that into an addition problem. But anyway, you're going to get a fraction here for a slope and leave it as a fraction. And you're going to get a fraction here for the slope. Now, you're going to compare those two. And if, when you compare them, that those fractions are negative reciprocals, that means the fractions are opposite and one's a positive and one's a negative. I shouldn't say opposite, it means the inverse. So I'll give you an example what inverse, slopes would look like. For example, if one of them is a positive 1/2, another one is a -2/1. You can see that on this first one, the denominator is 2, numerator is 1. Over here, that 2 goes up to the numerator, the 1 comes down, and that's a negative. So if you have something that looks like this, and it does not matter which one is negative and which one's positive, but you need a positive and negative, and you have to have reciprocals. If that's what happens when you guys simplify this, then we know then that those two lines form a right angle. And if they form a right angle, then we know that this is a right triangle. So that's your key, because slopes of perpendicular lines, these lines would therefore be perpendicular if the slopes are negative reciprocals. And then you can conclude with the perpendicular lines that that angle is a right angle and make your conclusion. So you finish it up there, but use my work to start with there. All right, so that's a little dicey. That's why I got you going on this one, because they switch gears from Pythagorean theorem to using something we did in a previous module this year. All right, hope that helps.